Welcome you all to the new session of computer graphics. Today we are going to see that how midpoint circle drawing algorithm can be used to plot the pixels on the circumference of the circle. Suppose the question is given like this: generate all the points on the circumference of the circle whose center is at 10, 10 and radius is 5. So from this it is clear that you have to plot the circle points along the circumference of the circle, and only two inputs are given to you, that is the center of the circle and the radius. So from these two inputs you have to identify all the pixel positions on the boundary of the circle. Clear? So let us start. So first, as given in the question, 10, 10 is the center of the circle, so I am going to write it as XCYC. That is circle center XCYC, which is 10, 10. It is already given in the question, and the radius R is equal to 5. These two things are already specified. Now, when I explained the algorithm to you, the first point or the starting point on the circumference of the circle should be plotted as 0, as this was already informed. This was the starting point or the first pixel of the to be plotted on the circumference of the circle was 0, R. So according to this, value of R is 5. So in this example, first point to be plotted will be 0, 5. Once the starting point is identified, you have to find the value of initial decision parameter, which is P0. Value of P0 can be found using the equation 1 minus R. Substituting the value of R in the equation, you will get 1 minus 5, which is 4. So given only two inputs, from these two inputs you have to find the starting point, which can be found using this equation, and you have to find P0, which can be found using this equation. So you got two new information, that is first pixel to be plotted on the circumference of the circle and the starting decision parameter. Now let us start the algorithm execution, and in each iteration of this algorithm you have to keep track of 5 information, which is the value of k, that is iteration number, the value of pk, next value of k, next value of y, and next value of decision parameter pk. So these are the 5 information you have to keep while doing each iteration. So let us start. In the first iteration, value of k is 0. When k is 0, pk becomes p0. So at iteration where k is 0, value of pk will be p0. So p0 is already found, which is 4. So value of p0 is written as 4. So according to the algorithm, if pk is positive, what we have to do? If pk is positive, then next value of x should be incremented. That is, next value of x is current value of x plus 1, which means x should be incremented, and next value of y means current value of y minus 1. So these are the points of x and y that are to be plotted. So clearly when pk is positive, x increments and y decrements. Clear? So according to this, in our first iteration, pk has a positive value. Since pk is positive, x will increment and y will decrement. So the starting point was 0, 5. So that is, starting value of x is 0 and starting value of y is 5. So from 0, x incremented to 1, and from 5, y decremented to 4. X incremented and y decremented. What about next value of pk? If pk is positive, then next value of pk will be pk plus 2 times the new value of x plus 1 minus 2 times the new value of y. So using this equation we will be finding the value of pk plus 1. Let us find. See, I am going to find pk plus 1. Since pk is positive, I am using this equation. So pk plus 2 times the new value of x minus 2 times the new value of y plus 1, which is minus 1. So in the next iteration, where k is 1, value of pk will be minus 1. When pk is negative, what should be the plotting points? According to the algorithm, when pk is negative, x should be incremented, that is next value of x is current value of x plus 1, but y should not be changed. Next value of y should be equal to that of current value of y. Okay, so according to this, when pk is negative, x increments, y remains same. So here in this case, pk is negative. So clearly x incremented from 1 to 2, but y has no change. Y is still 4. What about pk plus 1? When pk is negative, pk plus 1 is equal to pk plus 2 times the new value of x plus 1. So according to this equation, value of pk is written pk plus 2 times the value pk plus 2 times the next value of x plus 1. Now after some evaluating this equation, you will get the value as 4. So in the next iteration, where k is 2, value of pk is positive, which is 4. Since pk is positive, x will increment and y will decrement. X incremented to 3 and y decremented to 3. So we are not stopping at this position. Why? According to the algorithm, we have to continue execution until x is less than y and stop whenever x value becomes equal to y or x value becomes greater than y. So the condition of stopping is stop whenever x is greater than y or x is equal to y. So in this current example, when we incremented x and decremented y, both the x and y value became equal. So you can stop whenever these two values become equal or whenever the value of x becomes greater than y. So this is the stopping condition in circle generation algorithm. So after 3 iterations, our algorithm stopped. Okay, now what? According to the algorithm, with the starting point and the value of p0, when the algorithm proceeds and stops at a particular point, you have to identify the plotting points. So the plotting points are starting point, which is 0, 5. Here we have already identified that starting point is 0, 5. So it is clearly written 0, 5. Then all the points which were identified here, 1, 4 written, 2, 4 written, 3, 3. Okay, so all together we have identified 4 points starting from 0, 5 to 3, 3. 4 different points have been identified. Now what? Now after identifying the points to be plotted, we have to develop or we have to identify the symmetric points using 8-way symmetric method. We have to identify the symmetric points. How? So there are 8 octants. We already know that for a circle it is to be partitioned into 4 equal parts and every quadrant is divided into 2 equal halves. So altogether there are 8 octants. So let us write them. This is octant 1, and in octant 1 the point to be plotted is xy. In octant 2 the point to be plotted is yx. In octant 3 the point to be plotted is minus xy. In octant 4 the point to be plotted is minus yx. Remember, all these points were discussed in 8-way symmetry. And then comes octant 5. In octant 5 the point to be plotted is minus x minus y. Octant 6 the point to be plotted was minus y minus x. Octant 7 the point to be plotted was x minus y, and in octant 8 the point to be plotted was y minus x. Remember, first two octants belong to quadrant 1. So all the parameters, both the parameters will be positive. Only the difference between these two octants are the values of x and y will be interchanged. Okay. And these two octants belong to second quadrant, so clearly their first parameter will be negative and second parameter will be positive. Difference in these two octants will be reversing their xy values. These two octants belongs to third quadrant where both x and y are negative, and these two octants belong to fourth quadrant where the first parameter is positive and only the second parameter is negative. So the concepts are already discussed in 8-way symmetry. So you have to create 8 columns, one for each octant, and in each octant write the point to be plotted. Now before writing the points, one more thing. If I am going to plot the point xy, remember the algorithm says add xc to the first parameter and add yc to the second parameter. So clearly, if the value of x is 0 and value of y is 5, then you have to plot the point xy such that x is added to xc and y is added to yc. Similarly, in the second octant, the point to be plotted is y comma x. That means we have to add xc to the first parameter and yc to the second parameter. That means every time you have to add xc to the value of y and yc to the value of x. What about the octant, third octant? It is minus xy. So every time you have to take the value as minus x, and with minus x you have to add xc, and with y you have to add yc. So clearly, whatever be the point, whether it is minus xy or x minus y or minus y minus x, whichever may be the point, every time you have to add xc with the first parameter and yc with the second parameter, so that if the plotting point is y minus x, you will add y plus xc and minus x plus yc. Clearly? So in this way you have to obtain the points. Let us take a few examples. Let the points be 0, 5, 1, 4, 2, 4 and 3, 3. How we will write these points in each column? Let the first column be xy, so that it has to be written x plus xc and y plus yc. Value of x is 0. So 0 plus xc, you know that xc yc was the center point and the value of xc yc is 10, 10. Value of xc yc is 10, 10. Okay. So 0 plus xc, that is 0 plus 10, value of y is 5, y plus yc 5 plus 10. So the first point will be 0 plus 10, which is 10, 5 plus 10, which is 15. So first point to be plotted is 10, 15. What about the next point? 1, 4. That means you have to add xc to this value, yc to this value. Okay. So taking x as 1, so 1 plus 10 will give you 11. Value of y is 4. So 4 plus 10 will give you 14. Similarly, third point is 2, 4. So x is 2, y is 4. 2 plus 10, 12. 4 plus 10, 14. Next 3, 3. That is x is 3, y is 3. So 3 plus 10, 13. 3 plus 10, 13. So in this way you have identified the points in first quadrant. Now comes yx. So first value should be obtained by adding y plus xc. Y is 5. 5 plus 10. Xc is 10. 5 plus 10 is 15. X is 0. 0 plus 10. 10. Clear? And next 1, 4. So value of y is 4, value of x is 1. Y plus xc, that means 4 plus 10, 14. X plus yc, that is 1 plus 10, 11. So in this way this column will be found. Now comes the third column, which is octant 3. Find minus x plus xc. Minus x means minus 0 plus 10. Minus 0 plus 10 is 10. Y plus yc, 5 plus 10, 15. Taking the next point, 1, 4. X should be taken as negative. So minus 1 plus 10 is 9. Y plus yc, 4 plus 10, 14. Minus x plus xc, minus 2. X is positive, but here you have to take it as negative. So minus 2 plus 10, which is 8. Y plus yc, 2 plus 10, 14. So in this way this column will be found. What about this column? Minus y comma x. So first you have to take minus y. Here y is 5, minus 5 will be minus 5. Minus 5 plus 10, 5. X plus yc, x is 0, yc is 10. 0 plus 10 is 10. Next point is 1, 4. Taking y, that is minus 4 plus 10, which is 6. X, which is 1. 1 plus y, 1 plus 10, 11. So in this way first write the octant headings, which octant, and in each octant write the corresponding point, whether it is xy, yx, minus xy, minus yx, whichever may be the point, write the point, and then in every point with the first parameter add the value of xc, and with the second parameter add the value of yc. So in this way identify all the points. Clear? All the points in each octant should be identified. In every octant, whether it is 1, 2, 3, 4, whichever may be the octant, in each octant the points should be identified. Let me explain one more octant. Let it be this one, minus y minus x. First I have to take the value of minus y, that is, this is 5. So minus 5 plus 10, which is 5. Then minus x plus 10. Minus x is minus 0 plus 10, which is 10. In this way find all the points in all 8 octants. Once the points are identified, you can simply draw a graph where the columns represent the x values and rows represents the y values. Okay, now let me plot the point. First point to be plotted is 10, 15. That is, x is 10, y is 15. This is 10. So before plotting point, just draw some rows and columns and select any one pixel which is the center of the circle. So I am selecting this pixel such that this belongs to column 10 and row 10. As per the value given in the question, 10, 10 is the center of the circle. So after drawing all the rows and columns, you have to identify the center of the pixel, and this row 10, column 10, this pixel identifies the circle center. Okay, so the first point to be plotted is 10, 15. So let me identify which is 10, 15. 10, 15. That means this is the first pixel to be plotted. What about the next pixel? Next pixel to be plotted is 11, 14. 11, 14. 11, 14 means this is the 11th column and this is 14th row. 11, 14. So in this way you have to plot all the points identified in each pixel and plot them on this graph. Clear? And once all the pixels identified. That means the points which are already calculated in each of the octants are identified and they are correctly plotted on this graph. You can shade each pixel. Once the pixels are identified, you can shade these pixels, and then you can realize how your circle will look like. And this is how every point on the circumference of the circle is identified and plotted on the screen. So remember, using the algorithm, we have just calculated 3 points, because first point is already given, which is 0, r, and the remaining 3 points are calculated, which belongs to only octant 1. So algorithm calculates only pixel positions which belong to octant 1, and all the pixel positions which belong to the remaining 7 octants are automatically plotted using 8-way symmetry. So this algorithm helps you to plot all the pixel positions on the circle boundary with fewer calculations. Hope all of you understood how this algorithm works. Thank you.